Okay, here's how we could be sure about the greatest common divisor using linear combination. Okay, let's have an example. X cubed plus x minus 10 and x cubed minus x minus 6. These are two polynomials. We want to calculate their greatest common divisor using the linear combinations. They could be, for instance, in simplifying the fraction. They could be the numerator and the denominator of a fraction. Let's call this one f and this one g. Okay. Now, let's calculate f minus g, which is a linear combination of f and g. Here, these two cancel each other out, and that make the resulting polynomial is, in that there is no x cubed. Okay, so that would be x cubed minus x cubed, 0, x minus minus x, and minus 10 minus minus 6, which is minus 10 plus 6 minus 4. Okay, so this 2x minus 4 should contain the possible common divisor of f and g. Maybe it is their biggest common divisor or greatest common divisor, or maybe not. We should substitute 2 into one of them, but we could do another linear combination, f plus g, and that is 2x cubed minus 16, which is 2 times x cubed minus 8, and this is 2 times x minus 2. This is the difference of cubes, I think. Okay. Okay, and this is 2 times x minus 2. So we got two different linear combinations, and both of them contain x minus 2, and their biggest common divisor is x minus 2. But why? Here's why. F minus g equals to 2x minus 2, and f plus g equals to 2x minus 2 and this parenthesis. Okay, now add these two equations together, the left side of this with the left side of this and the right side together. Okay, you know, we could do that. It is like, you know, suppose we got 2 equality here, 2 equals 2 and 5 equals 5. Okay, and add these two and these two, 7 and 7, and the equality still exists. Okay, so after adding these two, these two g cancel each other out, and what got left is 2f equals to 2x minus 2 plus 2x minus 2 times this. Okay, and this is x minus 2 times 2 plus 2 times the parentheses. Okay, so f equals to x minus 2 times another thing, and now let's divide by 2 also. Will be 1 and 1 here. Okay, so f equals to x minus 2 times another polynomial, which means that f got the factor, the same factor of f minus g and f plus g. Okay, and so since f got this, then g also should have this, because if you subtract f from the both sides of the first equality, minus g would be a linear combination of f and x minus 2. So minus g also contains any common factor of f and x minus 2. So, but you know, the next question is why x minus 2 is the biggest common factor and not just any common factor. Why, you know, why x minus 2 is the greatest common factor, not just any common factor? Here's why. Suppose the greatest common factor is not x minus 2 and be some other thing, and the greatest common factor then should be equal to, should contain x minus 2, okay, and should be x minus 2 times some other factors. Let's call them or show them as h. Okay, then this h should appear also in both of the linear combinations. And I was saying that h should appear in every linear combinations of f and g, but here it didn't appear. That means that x minus 2 is the greatest common factor of f and g. And you know, this is for every linear combinations of f and g, not just f plus g and f minus g. You know, generally consider two general polynomials. for which we got two linear combination of those. AF plus BG equals to, say, big G times M and another linear combination CF plus DG equals to the big G again and times another polynomial. Okay, and here the greatest common factor of f and g is the big G, provided that n and m don't have any common factor. Okay, because for instance, multiply the both sides of this into a over c. So the first term of this times a over c becomes AF plus a over c dg equals to a over c gn. Okay, now for this one and the last one, subtract this equality from this AFs cancel each other out, and what got left is dg minus a over c dg equals to gn minus a over c gn. Okay, let's write it here, and this is g times b minus a over c b, and this is big G times n minus a over c n. Okay, this is a number. Let's divide both sides by this. This goes here. Okay, so the little g would be equal to the big G times another thing, which means the little g, which means that the capital G is a factor of the little g, and as before, is the greatest common factor of the little g and f. Because again, if you subtract bg from the both sides of the first equality, AF becomes a linear combination of the little g and the big G, so contains any common factor of the little g and the big G. Okay, let's have another example.